Welcome back, guys. So wireless controls are going to be the future of our industry. I mean, they're around, but it's going to be the future because we're getting better at this technology. So from Copeland on this podcast, we have Tom Lorenz, we got Randy Ruiz, and we also have Ben Reed, who's an expert on radio frequency because he's studied it and he's been into manufacturing with it in the past. So what we do here is we take a smart thermostat, the Sensi Touch 2. We control everything wirelessly to our indoor unit and our outdoor unit if we have two equipment interface modules from Copeland. Okay, we can use one. We can go from thermostat down to indoor if we want and end it there. But if we want to go wireless from indoor to outdoor, we can add one to the outdoor unit as well. So that's what this discussion is about. This is the future of the industry, guys. So pay attention. This is the HVAC Know It All podcast. I'm your host, Gary McCready. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. All right, Tom, we're going to start with you because you're one of the leaders on this product. But it's an EIM module. What does that stand for, Tom?
But yeah, equipment interface module.
Okay. All right, perfect. So what is it exactly? It's a wireless control. It allows you to communicate wirelessly from a Sensi Touch 2 thermostat to an air handler, then via an outdoor piece of equipment, right?
That's right. It really comes in handy when you don't have enough wires. When you're upgrading, especially like from an air conditioner to a heat pump, where you need more wires. And if you can't pull them, then you can put the equipment interface module, outside on that heat pump, and then it'll wirelessly talk to the Sensi Touch 2. So it's great for upgrades. And whenever you get into like I don't know, sometimes they call it problem solver. You're not going to need it all the time, but it's there if you have some wiring challenges.
Okay, so we'll get into some uses and advantages of a wireless product in a second. So Randy, you were the lead engineer on the product?
Yeah. I managed the hardware and firmware team that developed this product.
Okay, so what kind of process? Take us through the process of how do we go from start to finish on a product like this? Is there a couple of years of work done on this to get it to the way you want it to work?
Yeah, ideally we have a 12-month cycle time for our new products that we develop. So we'll start with, say, product requirements from Tom. And then we'll run through like various prototypes and fine tune it as we run it through our certification testing, which could be lab testing, like your ESD, your surge testing, and make sure that the product is hardened and robust enough to survive what things are going to happen to it out in the real world. And then from a firmware perspective, we'll run it through SQA, a software quality assurance program, to make sure does it do what we intended it to do. And then finally, once we get it fine-tuned, we'll start field testing it, right? Find out, does it do what the customers are expecting it to do, right? And then after that, we get their feedback, fix some more bugs, and then we're about ready for prime time at that point.
Okay, cool. All right, so we'll come to you, Ben, and you have some expertise in your past life on wireless communication. So maybe set that up for us. We'll come back to you now and again during the podcast. But what is your expertise or your background on wireless communication?
Yeah, thanks, Gary. I've done about just over 10 years of working with small teams prototyping IoT products. And so a lot of kind of research in the lab, field deployments. And one of the ways that I got into HVAC was with one of the startups that I worked with, which is Haven. So they're out of Vancouver, and very small team, but we kind of had a very similar process to what Randy explained there, where, we'd have the hardware, we'd be developing the PCB designs. We send those out to a PCB manufacturer. We'd get the kind of those pieces back. We'd assemble them maybe with 3D printed enclosures, and then we'd do firmware development and firmware testing. And then, like, after that's all done, then we would kind of prep it for production. So it's a very lengthy process with like so many little nitpicky details, because you really want the product that you release, it has to be reliable. Especially what I found in the world of HVAC is that kind of any downtime, any sort of bad taste when a product first comes to market will impact the uptake of that product in the market for years and years to come. And so with Haven, it was really eye-opening to kind of just see how time-consuming and how careful you have to be during that development process. So Randy, really interested to kind of learn more about kind of how that all worked in your world and how you guys brought it to market. I have lots of questions, but I'll kind of save them for the rest of the podcast.
Cool. Okay, so listen, Tom, why would somebody, because wireless controls, I think, is going to be the future. It really is. You can just, I've made predictions in the past when I see certain things like press or digital smart tools. And I've always said these are the future. Just looking ahead, what are people going to be using in 10 years from now? And a lot of times when you make bold predictions, you get people that laugh at you. And then 5 years later, those bold predictions start to actually show like they might have some truth to it. And then you kind of get the last laugh. It's just about look at the world around us and what are things advancing towards. And I mean, when TV remotes went wireless, I mean, that's an indication that more things are going to be. I remember getting up as a kid and having to go over the TV and push the buttons on top for my parents, right? So I'm still in those days myself as being like a mid-40s guy, like the old wooden TVs with a tiny little screen in the middle, and the control was a big clunky box on the top that you had to press. Then we went to wireless controls. So that was kind of probably one of everybody's first experience with wireless controls, or maybe like a remote control car or something like that. So what was the purpose for Copeland to create something like the EIM? Like what was the purpose behind it? What's the problem that we're trying to solve?
The problem is not having enough wires, but techs get more used to the wireless technologies, they become more familiar with it. And then, who knows, you're right. Maybe in the future we won't have any wires. So, but yeah, it was all about actually my mom's house. She had a tech came out there cause she didn't have cooling, and, he found out a rat or something ate the wire inside the wall. So she lost cooling. So I was like, what? There's no way. How do you break a wire? But yeah, so this is just a great solution when you don't have enough wires.
But we need particular wires to go to the module. And what are those wires that we need to go to it?
Yeah, so it needs power. You need 24 volts to the thermostat and then 24 volts on the module. And then the module, of course, you wire it from furnace or air handler or the heat pump or AC unit. So
okay, so let me bring up a scenario where this could work. So it's an older home. Maybe they're doing some upgrades or renovations, and they've just got basic heating, and they've got 4 wires. They've got a 4-conductor thermostat wire going from the indoor unit to the thermostat. Now we're implementing cooling. We're going to use like a heat pump, or we're going to use dual fuel or something along those lines, because that seems to be a big push, right? A lot of people are going heat pump, and they're putting dual fuel as a gas backup or gas auxiliary. If you've only got the 4 wires there, a lot of these heat pump installs need like an 8-wire conductor ran, because there's a lot of things implemented going back and forth. So this is a good case where we could use the EIM, right, in place of those wires, because even though it needs to be powered, the actual communication of the heating, the cooling, the fan, that's all done wirelessly, correct?
exactly. Yeah, you nailed it.
Okay. Now, the other important thing, Tom, is it's waterproof. So we can put it outside. We can mount it like outside of the outdoor unit. It doesn't have to go inside it, correct?
That's right. It's weatherproof. It's great for the outdoor being weatherproof, but also, even on the indoor side, if you have a drain pan or leaky humidifier and it drips on it, it's waterproof there too. So a couple benefits inside and outside.
So Tom, I wanted to ask you a question regarding the power, because we have to run power to the module, but we don't need to have wires running from the inside to the outside for that. We can actually install a step-down transformer in the outdoor unit and have that module sitting standalone basically out there, right?
That's right. Completely wireless if you mount the transformer outside. Yep.
Okay. All right, Randy, the outdoor module and the indoor module are the exact same, designed the exact same way. There's no difference between them.
It's the same part.
It's the same part. So it's one SKU. So what would be the advantages of having having one at the indoor and one at the outdoor unit? Or what do you guys recommend? Do you recommend one, or do you recommend putting two on a system and using it with the Sensi?
Well, I guess it's really on the installer, right? Do they want it to be completely wireless from the indoor to outdoor, and completely wireless from the thermostat to the indoor, right? Where do they need to run wires?
Okay. So if they wanted to cancel out all wiring besides power, they could have a module at the indoor unit and one at the outdoor unit. And now it's total wireless communication.
Right.
Cool. Okay. Ben, what are your thoughts on that?
It's a great solution. And what I'm really curious about is, the cost is on the business side, if an HVAC company or a homeowner was evaluating whether to put in the EIM, let's say inside, outside, or maybe just outside versus running a wire. Have you guys done estimates of what the cost difference would be for the labor and the parts for running the wire from the inside to the outside versus putting in that EIM? Because that could make a very, easy decision for somebody. Because I would also assume that was one of the primary, decision-making factors when you decided to green light this product, is to be like, you know what, this is going to be within the price range that it makes sense to install this instead of running a wire. So do you have any of those numbers for us?
Yeah, I can share with what the contractors have told us. If they have to pull wires and bring in, someone to do construction work, or it could take an hour of their time to pull wires and to fix, the patch holes, or, whatever they need to do to get wires. So they said that average is about $350. So to save them an hour. Plus, then they can get to another job and they'll make more money and they don't have to spend that time.
I'm going to give you an example of something that was way more than an hour. This might be on an average thing. That could be new construction, whatever it is, or if it's existing. But I was changing out a furnace. The customer wanted to go completely zero gas, and so we put in a heat pump. We put in it with a heat pump air handler that had electrical backup or electrical auxiliary, and we put in a thermostat. So this was a 5-level back split. So getting from the thermostat down to the air handler was going to be an impossible mission without cutting holes in the ceiling, holes in the walls, and probably cursing a million times trying to get this wire run. So the thing that was done here, and I won't mention the thermostat's name, or I could, but you guys might get upset with me. Anyway, so what happened was we had to put a thermostat in the mechanical room, and we had to put a sensor up where their thermostat was, and then they just used their phone to control it. Because then we just basically ran all the wires from the air handler right to the thermostat that was mounted right beside it. But that thermostat wasn't responsible for monitoring the temperature of the home. It was only responsible for monitoring or controlling it based on what the sensor in a remote location was telling it. So that was how we got around that one. But now that I know this product exists, this would be something that I would use in that kind of situation. Randy, what are your thoughts on this scenario?
Yeah, I mean, that was our primary objective, is ease of installation or speed of installation for when you're updating your equipment. As there's mandates out there that people are going to the heat pumps, right? That's the trend we're trying to solve for people.
Mm-hmm. So how difficult is this from a setup standpoint, Randy? How difficult or how easy is it for a contractor once it's installed, it's mounted, the power's run? What is the, the methodology behind how we set it up? What is the steps we take on how to set the thing up? Does it take 5 minutes? Does it take an hour? Maybe take us through some of those steps.
Oh, it's pretty simple. To connect the EIM to the thermostat, once the EIM has power, it starts advertising itself. And really, you just go to the thermostat menu, you click the EIM button, and then you'll see the EIM appear. You'll click that, and it'll automatically pair to that device. And at that time, that's when you'll decide if it's an indoor or outdoor EIM.
Mm-hmm. Cool. So that also gives you the capabilities of, again, I know it sounds like a silly question, but some people might be thinking, if I'm on vacation somewhere, if I'm in Jamaica, right, and there's an issue with my house, I can check on it and I can turn up the heat or turn down the cooling or something using the wireless technology still, right? We can still control it from a remote location.
Yeah, it
Okay.
uses our traditional Sensi Touch 2. So it's
Yep.
it's the Sensi Touch 2 that we already sell today. We just added another firmware feature to it
Okay. And is that the only thermostat we can use with this currently is a Sensi Touch 2?
currently.
Okay. All right. So Ben, coming back to you on your experience with wireless communication, what advantages does wireless communication give us? I mean, there's people out there that will say wired all day, because we don't have to rely on parts failing. But there's people out there that say, you know what? I've been using wireless and my Bluetooth tools and this and that for years, and I love it. So tell us some of the advantages of using a wireless communication over wired, in your opinion.
Yeah, well, everything's a trade-off. Because there's no free lunch. The wired, it'll always take more time, more money to implement that, and the result might be more reliable communications, especially in extreme situations. And so, like, take just as a use case in factories that have like a lot of very sensitive equipment. Oftentimes you go with like specialized shielded wired communication methodologies because there's a huge amount of electromagnetic interference and you can't have any downtime. But that, like, the costs for that are astronomical. So in consumer applications or even in just residential applications in general, we've kind of reached a point where the wireless technologies are actually at a level of reliability and also a level of, I guess, sensitivity that they can have long ranges without downtime at reasonable costs. So there's been huge advancements in the last decade, like the last couple of years, even on making those radios that are inside those embedded devices to be extremely cheap and also extremely reliable, even in some challenging situations. And so, like, I think that in the last couple of years that the hardware has finally crossed the threshold where in the majority of situations, it makes financial sense to be able to deploy a wireless control system versus a wired system, because time is the one thing that we can never get back. Time is the most valuable asset that anybody in this industry has. And so this wireless application is fixing the time problem, which is one of the most difficult and most important problems to solve in the industry.
Yeah, no, I totally agree. And time is everyone's most valuable asset, not even just for the industry. So if I can install something quicker as a self-employed person and get home quicker so I can pick up my kids from school or something like that, instead of being in someone's basement cursing and swearing, running wires through it, then yes, I'm probably going to try to lean on that technology so I can save time for myself. So, Tom, I want to ask you this. So anything that the Sensi Touch 2 can control, make us maybe tell us what the Sensi Touch 2 can control. Heating, cooling, is there any sort of auxiliary control in there for humidification or anything like that? Maybe take us through that and let us know, can we do all of this through the IEM or the EIM? Sorry, that's a hard acronym to get right sometimes.
For sure. Yeah, walk us through that. So the EIM can control up to 4 stages of heat. So 2 stages of heat pump and then multi-stage, indoor unit. So that gets you 4 heat stages and then 2 cooling. So yeah, it's a 4 heat, 2 cool. Covers the majority of systems out there. And then it also controls IAQ equipment. So you can hook up a dehumidifier, a humidifier, and even ventilation. And you can control all that from your Sensi Touch 2 thermostat. So you configure it. You can put lockouts in there. You can do pretty much anything you want with hum, dehum, and ventilation. They can work independent of the system or with the system.